Hello guys, so good afternoon. So this video is a reinforcement video or a discussion on what you did in the experiment this week. So this week, your researches were about the principles on analytical procedures that we are doing in the laboratory. So class, so yung tanong na sinasagot basically ng activity natin is how do we measure the concentration of an analyte? How do we measure the concentration of an analyte? So class, if we measure a concentration of an analyte in the clinical chemistry, it is very precise. Isn't it that we are very accurate down to the decimal places? Kunyari, class, we are measuring for glucose. So, example, yung result ng glucose niya is 120.9 milligrams per dl. Yan, it's very precise. Yan. So, the way we measure the concentration of glucose in serum is spectrophotometry. Yan. So, the topic that encompasses the topic that is highlighted during this week is spectrophotometry. Sabi niya, spectrophotometry is a measurement of how much a chemical substance absorbs and transmits light. So class, each analyte, just like your glucose, yung mga next na topic natin, HbA1c, the different lipids class, these analytes have different characteristics. They have different characteristics on how much light they absorb, they transmit. So, absorb, hinihigop, transmit, pinapasa. Yan. So, iba-iba yung characteristic nila on how they interact with light. So, class, ang galing ng mga engineer. So, they use this principle to measure the concentration of the analyte. So, ma'am, yung light, pag na-transmit na-absorb, how do we measure it? So, using a spectrophotometer. So, a spectrophotometer is an instrument that measure how much light is absorbed. And how much light is absorbed, transmitted, or emitted reflects the concentration of a sample. Class, ganon. So, example, dito sa lagyan na to, in this image, class. So, that, yung mga black na dots, class, these are the analytes, yan. So, how, the concentration on how much these analytes would absorb light or transmit light, depende sa principle ng analytical method. So, that would be it would reflect the concentration of the analyte. Yan. So I hope that you understood that the amount, how much light is absorbed, transmitted, or emitted reflects the concentration of the analyte. So ang galing, no? Class, they used light to measure the concentration of an analyte. Yan. So class, in other terms, your light is also called your electromagnetic radiation. Yan. So, under spectrophotometry, you have to get to know light. Yan. So, your light, so could be cosmic light, gamma rays, X-ray, light, tong mga to, UV ray, class, nakakapatay ng COVID-19, visible light, class, these are types of light, infrared light, microwave light, and radio waves. Pero ang best term is wave. Yan, microwave, infrared wave. Ganyan. So, class, so this light or electromagnetic radiation, guys, have wavelength. Yan. So, eventually, if we're going to use a spectrophotometer and we have a test reagent, yan. So, the process will require a specific wavelength. Yan. So, class, yung wavelength natin is actually sineset na nung manufacturer. So, yung role natin as medtech is ipa-follow yung wavelength na recommended ng manufacturer sa reagent niya. So, usually, yung wavelength, pinipili ng manufacturer based sa color ng end product. So example, class sa glucose, kung di ako nagkakamali, may pagka-pink. May pagka-pink yung end product. Yan. So to measure the analyte of glucose molecules, yan, it's better to use the wavelength closer to pink. Ganyan. So closer sabihin natin to violet. Yan. Medyo may pagka-light violet. So, the wavelength could be around 420 nanometers. Yan. So, depending on the product, ganyan, on the analyte is the wavelength. So 400 to 700 nanometers, so nandiyan 70, is your visible spectrum. Yan. So less than 400 nanometers is your ultraviolet region and more than 700 nanometers is your infrared region. So usually class in our spectrophotometer machine, what we're going to use is your wavelength within the visible spectrum. Yan. So kung kailangan na ng ultraviolet rays, yan, example, yung light source mo, cathode ray tube, ultraviolet rays yung ano nun, yung lamps natin class, yung typical na lamps natin, visible wavelength yung ine-emit nila. Pero pag yung cathode ray tube glass, ultraviolet. So example na makina na gumagamit ng ultraviolet rays is your atomic absorption spectrophotometry. So ibig sabihin, kapag cathode ray tube, UV light yung ginagamit. So ibig sabihin yung wavelength doon class is less than 400 nanometers. So, yan. So, get nyo. I think na-discuss nyo naman sa lecture. So, class, in spectrophotometer, it's very important that you would know the basic parts of this basic components of a single beam spectrophotometer. So, dapat memorize nyo na yung light source natin or exciter lamp. So, this would be our source of electromagnetic radiation. So, pwedeng visible light, ultraviolet light. We have your letter B, entrance lit. Letter C, your monochromator. Letter D, exit slit. Letter E, or number 5, yung cuvette natin, where our sample will be placed. Letter F, yung photodetector natin. So, it will transmit the electromagnetic radiation into a electric current. At letter G, or number 7, yung readout device niya. So, i-interpret ni readout device kung ano yung na-measure ni photo detector. So, class, discuss lang natin ng onte. So, wag kakalimutan ang light source or exciter lamp. So, usually, tungsten tayo. Hindi LED light, tungsten. Yan, most common used. We have deuterium. Yan, so yung sa mga ang tawag, sabi ko kanina, yung cathode, wait lang. Yan. Hollow cathode lamp, cathode ray tube. Hollow cathode lamp class. So it emits UV light. So the UV light, the source of the UV light is deuterium. Yan. We also have hydrogen lamp, xenon, so UV rin. We have MERS glower, infrared. So sabi, class, important note, when a lamp is changed in the spectrophotometer, the instrument must be recalibrated. Yan. So every time you're going to change a lamp, you have to calibrate your machine. Yan. We have entrance lit. It minimizes unwanted stray light. Yan. Because class, kasi your photodetector is very sensitive to all light. Yan. To all light. So, dapat makontrol yung amount of light entering our system. And entrance lit. Minimize the light. Yan. So, stray lights refer to any wavelength outside the band transmitted. It may lead to a systematic error. So, we have wavelength selectors, or also called your monochromators. So, they are the one which chooses or isolates the wavelength. Ayan. So we have either prisms, diffraction gratings, and filters. Sabi dito, glass filters and interference filters are used in photometers. Diffraction gratings and prisms are used in spectrophotometers. So, wavelength accuracy. So, this is quality control activity. Wavelength accuracy is checked using the muon or holmium oxide filter. So, class, naku, pakiano lang yan Yan, huwag niyo kakalimutan yan. So, class, the link of the PDF, I will place it under the video. So, class, we have exit slit. Yan. Selects the bandpass. So, ayan, nandan yung what bandpass mean. We have different cuvettes. Yan. Sabi niya, cuvettes with scratches because scratches can be interferences. Yan. Should be replaced or discarded. And we also have photodetector. Yan. So, it converts your electromagnetic radiation into an electrical signal. Yan. So, we have different kind of photodetectors. Yan. PM, diode. So, yan. Please, pakibasa lahat naman nandyan na. Yan. And we have readout device. Yan. So, class, I just want to emphasize this Beer's law. Yan. Beer-Lambert's law. So, Beer-Lambert's law, class, is very important in computing for the concentration of our unknown solution. Yan. So, to solve for the concentration of unknown solution is absorbance of the sample, so absorbance of light of our unknown sample over the absorbance of standard. So, ito na yung standard na pinag-uusapan natin, di ba, may primary standard, ganyan, times concentration of the standard. So, itong concentration of the standard, class, makikita natin to sa primary standard kung ano concentration niya nakalagay doon. Yung absorbance, class, absorbance is a data that is collected from your spectrophotometer machine. Yan. Makikita mo to sa readout device. So, pag ni-read mo sa spectrophotometer, ang result na ilalabas niya is yung absorbance. Yan. So, you should take the absorbance of the unknown and the absorbance of the standard times concentration of standard. So, class, this formula is derived from your Beer's law. Yan. Your Beer's law. Sabi niya, states the concentration of a known substance is directly proportional to the absorbed light and inversely proportional to the transmitted light. Yeah. So as the absorbed light increases, the concentration of the unknown substance increases as well. So pag mas maraming na-absorb na light, it's a sign na mataas yung concentration ng substance. Yan. So kung mababa yung absorbed light, mababa rin yung concentration of the unknown analyte or substance. However, it is inversely proportional to the transmitted light. Yan. So, the transmitted, yung hindi na-absorb. So, your Beer's law, so yung pinaka-original na ito yon. So, A is equal to, absorbance is equal to A times B times C. So, actually, itong absorbance is kinocompute na ng photodetector. So, small a is your proportionality constant or molar absorptivity. So, class, this is a constant, meaning there are different absorptivity ang mga analytes natin. So, some analytes like glucose could be has a good molar absorptivity. Some analytes do not have good molar absorptivity. Yan. How well a compound absorbs it. Okay, next is path length. The distance light have to travel through a substance. So, class, the width of your cuvette, kung saan nyo nilagay yung cuvette nyo, that's your path length. The distance light have to travel through a substance. Syempre, pag mas marami yung laman, longer width yung cuvette nyo, ibig sabihin, mas mahaba ba yung path length? Tama? So, pag mas maikli, mas manipis yung cuvette mo, mas maikli yung path length. Why? Siyempre, pag mas mahaba yung path length, mas maraming analytes tends to have more analyte. Pag mas konti yung path length, yan, depende. So, yun. So, it could affect the concentration. So, that's your Beer's law. So, yun na. So, class path length is the distance light to travel through a substance. Yan, syempre, pag mas marami siyang dinaanan na substances, yan, it would affect the concentration eh. So class, we have different instruments that reads your absorbance. Yan, photometer, spectrophotometer. Yan, ito yung madalas natin ginagamit. Colorimeter and spectroscope, optical instruments. So ginagamit na optical for visual of atomic emission light. Oh, okay. Ito pala, colorimeter, you use your eye. Yan, as the detector. So class, just a overview or just a brief class. Emphasize lang. So we have single beam spectrophotometer. So isang exciter lamp, isang entrance, isang slit, isang monochromator, isang exit slit, isang cuvette, isang photodetector, isang readout. Yan. Very simple. Single beam spectrophotometer. Pero meron tayong double beam spectrophotometer. I think diniscuss naman ito ni ma'am ng lecture nyo. So double beam in space, it has 2 photodetectors. Yan. Two photodetectors. Yan. Isang reference beam. So yung isang light pumunta sa unknown substance, yung isang light pumunta sa reference substance. Yan. So, pag single spectrophotometer, kailangan mo ipasok yung yung cuvette ng pasyente, tanggalin mo, tapos ilagay mo yung standard mo. Or, sorry, nauna yung standard, tapos yung cuvette ng pasyente. Pag single beam. Pero pag double beam in space, since dalawa naman yung photodetector mo, dalawa yung papasukan. So, you could read it simultaneously. Yan. So, it saves time. Yan. Double beam in time class uses one photodetector and alternately passes the monochromatic. So, double beam in time. So, isa lang yung photodetector. So, meron tayong chopper dito. Yan. A chopper is the term that used for device such as rotating sector mirror that breaks up or rotates the beams. Yan. So, class, for the rest of the machines, sobrang short lang yung pagka-describe ko. Yan, maikli lang yung pagka-describe ko. So, please, go over it. Yan, iiwan ko na sa inyo. Please go over it. At alam ko na-discuss naman sa lecture. Pero sige, kasi nga, yung mga itatanong ko, alam niyo naman, andito rin lang naman. Yan. So, please, study it well. Yan, spoon feeding na pag-discuss ko isa-isa. So, guys, I hope that you're going to study well. And siguro magbigay lang ako ng example. Ito, atomic absorption spectrophotometry. Hindi ko makalimutan to kasi we used this when I was in undergrad. So, ang thesis namin, trace metals sa tubig. Kasi nagkaroon ng garbage slide nung panahon na yon. So, yun. So, AAS is good for measuring trace metals like your lead, mercury, calcium, magnesium. Yan. So, iba na naman yung nito. Ito nga, hollow cathode lamp. So, ang source niya, UV yung ini-emit niya. So, yan, may chopper. Yan, may monochromator, may PM. Walang exit at entrance slit. FES versus AAS. FES is flame emission spectrophotometry. And AAS is atomic absorption spectrophotometry. Sabi niya, yung FES, intensity of emitted radiation, is directly proportional to the number of atoms in excited state. Yan. So, ang minimeasure dito, yung radiation, pag excited ang atoms. Ito naman sa atomic absorption, yung minimeasure mo, yung na-excite yung nung na-excite yung atoms hanggang napunta siya sa neutral or ground state. Yan. So, ganun siya. So, ito ground state, ito excited state. Mga ganun, class. Nephelometry, the scattering of light. So, ang minimeasure niya, hindi yung absorption of light, but yung scattering of light. Yun, class, yun yung mga contents nito. So, class, kayang-kaya niyo yan. Yan. So, hanggang chemiluminescence to. Yan, chemiluminescence. So, coming from the word chemiluminescence is may chemical reaction. So, yung chemical reaction, so walang ilaw dito, class, but walang exciter lamp. Pero ang nagpapa-excite dito, class, is yung chemical reaction. Wala exciter lamp, but we have a chemical reaction. So, yun. So, we measure the photons or the atoms once they go to the ground state. So, pina-excite mo sila, tapos hanggang punta sila sa ground state through chemical reaction. So, ang ano naman dito, no excitation radiation, so no excitation lamp, and no monochromators, kasi nga walang wavelength. So, class, ganun lang, super short lang yung mga descriptions ko. Yan, no potentiometry, colorimetry, yan. So, example pa, mass spectrophotometry. So, ang pinakasikat na ng mass spectrophotometry, mas maganda to pag nakadikit sa gas chromatography. So, we have this term as GCMS, gas chromatography and mass spectrophotometry. So, sikat na sikat ang GCMS class as a gold standard for confirmatory test in drug testing. Yan, in drug testing. So, kung PCR ang confirmatory test ng COVID-19 testing, ang drug testing class, ang confirmatory niya is GCMS test. Gas chromatography, mass spectrophotometry. Yan. So, sa mass spectrophotometer, anong minimeasure? So, ganun, class. Yun. So, class, that's all for today. Thank you for listening. Bye-bye. Happy studying. See you next week.